Today, let us begin with Kubernetes, the container orchestrator tool. We learned already Swarm in this category. So, what are the differences? How different is it from Swarm? Let's take a look into the differences. Both are container orchestrator tool, but Kubernetes is far advanced and widely used because of all the advanced features. This is the tool which we use mostly. And what are the differences? Yes, both of them orchestrates, but again, the architecture is completely different. The architecture of Kubernetes is different from Swarm. Swarm has a simple architecture, whereas that's not the case with the Kubernetes architecture. And Swarm, you can orchestrate only Docker containers. Whereas in Kubernetes, we can orchestrate containers from different runtimes. You have different runtimes, right? Like we learned, there are other tools like along with the Docker, like a Rocket, OCI containers, and so on. All of those can be orchestrated with Kubernetes, whereas it's only Docker containers for Swarm. Okay, that's the first major difference. And then the learning curve is steep in Kubernetes, whereas it's simple in Swarm. Like you don't have to learn the commands separately. They're almost like Docker commands, right? But again, commands are different in Kubernetes. And also, it's a very easy to learn. Swarm is easy to learn and easy to set up. Kubernetes setup is complex as well as a learning curve is steep. Those are the very simple or the basic differences at this point of time. We would see more differences with respect to architecture, the functionalities, the behaviors and all. Right, Kubernetes provides has got inbuilt resiliency feature, which helps to build robust systems. Right, how this works and all we'll see. Also auto scaling possible here in Kubernetes. In Swarm it's possible but not as effective as Kubernetes. Also zero downtime of applications possible. Zero downtime during upgrades. Like let's say you're running version 1, you want to deploy version 2, right? During this time there might be some downtime seen, but with Kubernetes you can have zero downtime during these upgrades. Also there are different deployment strategies like a blue, green, canary deployments, and so on in Kubernetes, which helps you manage your deployments better. So, so these are some of the basic differences. Let's get started with the Kubernetes to see the actual differences. And before that, first let's get into the Kubernetes architecture. But before we progress, any questions from anyone? And do you have any questions?
This Kubernetes, you said some, I mean, a runtime. I mean, runtime means you can, it is supported for the, I mean, Docker, Rocket, OCA, these three things,
Yeah,
right?
Docker runtimes. Here it can manage only Docker containers, whereas Kubernetes can manage containers from different runtimes, like Docker, Rocket, OCA, different runtimes. Any more questions? All right, let's get started with the Kubernetes architecture. Like you'll have a Kubernetes cluster, like we have seen Swarm cluster, and it's a combination of a bunch of nodes, means bunch of Docker hosts or Docker engines. Here also you could see the same, and these are called as worker nodes. You can have any number of worker nodes. There also we call them as worker nodes, right? So in Kubernetes clusters, we call them as worker nodes or simply Kubernetes nodes or way back they were called minions, but now we call them as worker nodes. And there is one control plane in the cluster. This is called the master node or control plane, which manages the entire cluster, right? So it's a combination of manager. Here we call it as a master. It's a combination of master node and worker nodes. In Kubernetes, strictly no containers on the control plane, right? Control plane is nothing but master node, no containers. It's a dedicated server to manage the entire cluster, right? So this is how you have it. First, let's go through. Again, every node has got its own different components. So let us go through those components. Worker node has got the components like the first component, let us go through, which is Docker. Docker is the first component. Then you have kubelet, kubeproxy, and pods. Let's go through each one by one. First, coming to the Docker. like we discussed, that's a Docker runtime, Docker engine, Docker daemon, whatever you call it, should be present on every worker node, right? That should be present on every worker node. That's a Docker container runtime. Second component is kubelet. Kubelet is called as the Kubernetes agent running on every worker node. It is the one which interacts with the master node. It interacts with the master node, right, to have the communication. So that's a Kubernetes agent running on every node. Kubernetes master node communicates with the each worker node through this kubelet, right? So that's the second component, and this is the one which takes the instructions from the master node and deploys the containers or pods. I mean, starts the pods on the worker nodes. So that's a Kubernetes agent, kubelet, which is running on every worker node. This kubelet should be running on every worker node for it to function. Okay, that's the second component. Third component is the kube proxy. Kube proxy is nothing but which will take care of networking or communication between different containers in the cluster. Like it is the one which is responsible for containers on the same node to communicate, or containers on different nodes to communicate. So kube proxy is like network brains of the cluster. Those are the first three components which resides on every node in the cluster, right? First three components. Then comes the next component called pod. What is this pod? In a Kubernetes cluster, you will never see container like this. What does it mean? You will always see container wrapped around a layer called pod. Pod is nothing but a layer around your container. Your container lives inside the pod. Pod is like a living environment, home for the container, right? Container lives inside the pod. Pod is the basic fundamental unit of deployment in Kubernetes cluster. You deploy the pods, you scale the pods, you work with the pods, you delete the pods, you basically deal with the pods, right? Not with the container. Like I told you, pod is like a living environment for your container. Your container lives inside the pod. Every pod will be assigned with the IP address, not the containers. Pods will be assigned with the IP address. And if you want to access a particular container, you access that pod IP on some port. A pod will have some network interface. The same network interface is shared by that container. So containers lives in the pod, and the general practice or the regular practice is one container per pod. That's a general practice. But you can have multiple containers also in the pod. Right? You have multiple containers in the pod. You can have it, but that's a rare use case, but generally one container per pod. And let's suppose I'm running Nginx container. It will be inside a pod. If you want to scale the pod, yes, you'll have so many pods created wherein you will have that Nginx container. This is how you replicate. But it's not that when you replicate, this is not what it means by replication. No, same container. C1 means imagine they are both from Nginx. No, this is not correct. This is not the correct thing. You scale means you will get a separate pod with a container running in it, right? You may have this. When I say C2, it's a from different image, like let's say Nginx image, and then this is Tomcat. This is possible, but very rare use case. Got it, everyone? And also, whenever you run the pod, a complete pod will be deployed on one worker node. It's not like half pod on one worker node and half pod on another worker node. Means, let's say a pod is having two containers. All of that will be in the same worker node. Okay, so that is
So
about pod.
this one, can you please explain again, that C1, C2?
C1, when I say C1, they're all coming from same image, replicas. Let's say I'm running Nginx. I want to run 3 Nginx containers. So when you replicate it, you'll get a separate pod with a container in it. That's how you scale, but not a containers increase in the same pod. But a container can have multiple containers. That comes into picture where you run multiple services inside a pod. Like C1 is Nginx, C2 is something else. That's possible. Understood?
Ma'am, how container and pod connected?
We'll see that, okay? How you create them, how this pod runs, a container runs inside the pod. We'll see. There is nothing like you deploy pod a container in a cluster. You deploy only a pod. Means container with a wrapper. That's it. So this is how you have the 4 components on every worker node. Of course, these pods are what we deploy, what we run as part of our application. These are the 4 components on every worker node. Is this much clear for everyone?
So
Understood?
worker node itself only we need to run our applications, not in master node, right, madam?
Correct. Correct.
So this is the rule.
This is the, what is that rule or rule you are saying? Yes.
Yes, okay.
Mm. Containers like in Swarm, containers would go on land upon Swarm manager node also will drain it, right? But here by default master will be drained. You can't put any load on master.
So ma'am, this worker node 1, 2, these are clustered right now.
Nodes in a cluster.
Nodes in a cluster.
What is a cluster? What is a node? In the last class I have explained. Cluster is nothing but bunch of Docker hosts. Docker host is a VM or a physical server or an EC2 instance where Docker is running. In Swarm or Kubernetes, cluster is a bunch of Docker hosts or Docker engines or Docker daemons, whatever you call it. Host is nothing but VM or a physical server or an instance, a cloud instance where Docker is running. Bunch of Docker hosts are is a cluster.
So here worker 1 plus worker 2, uh, these two are known as the cluster, combining together.
Control plane also, master node is also. All of them put together is a cluster. Out of this bunch of Docker hosts, there will be worker nodes as well as master nodes. Master node is the manager which will manage the cluster. Were you all available in the last class where we discussed this in Swarm, Docker Swarm?
Ah,
Yeah.
yes, ma'am.
Then we have seen there, right? There is one manager, 2 worker nodes. That's a Swarm cluster. Same is the case. Cluster is a bunch of nodes. Nodes means worker nodes and manager node. Those are not simple VMs, VMs where Docker is running. So now that we understood the components of worker node, let's look into the components of manager node. Here, if you see, there are different components like API server, scheduler, controller manager, etc. These are the different components. Just a second. Sorry, 1 second. Please give me. Yeah. So these are the different components we have. API server, scheduler, controller manager, and etc. What is API server? API server is called brain of the cluster, right? So that's a core component of the cluster, that's a decision maker. Like any inputs given to the cluster taken care by API server means you give the inputs to your cluster. Let's say I need 4 containers or 5 containers. Those things, those commands, those instructions you would be giving through CLI or UI. Yes, Kubernetes has got UI also, but it is very rarely, very less used. Maybe let's say 2%. Okay, so 98% of the time CLI is the one which is used. You should learn the CLI only. So we will be giving instructions through CLI, and those instructions will be validated by the API server, the brain, the core component of the cluster. It will validate it. Let's say we are saying, okay, 4 containers should be deployed. It will validate the request and then it will interact with the next component called scheduler. As the name says, scheduler is the one which schedules the containers on the worker nodes. So scheduler is a component which will decide where to schedule, when to schedule. Okay, 2 containers should be scheduled on worker node 1 at 8:30 a.m. Something like this. Kind of scheduling is done by the scheduler. Where to schedule, when to schedule, what to schedule. All of this will be taken care by the scheduler. And then those instructions will be given to the kubelet. Like I told you, right? If it has to schedule, how it will do that? API server will send the instructions to the kubelet. Kubelet is a component with which it would interact. That's what it's called as a Kubernetes agent running on every node. So that's a scheduler thing. And also, how does API server? Okay, fine, it has scheduled. Okay, later on, there is one more component called controller manager. It's a manager of different controllers like node controller, pod controller, API controller, endpoint controller, so many controllers. Basically, controller manager is like a watchdog which will watch the cluster always for expected results across actual results. What are expected results? Expected results is what you define here. You write the instructions in the form of a manifest file. Kubernetes always prefers declarative approach. This is another difference between Swarm and Kubernetes. Declarative approach means you write the manifest file. Manifest file is written in YAML or a JSON. YAML is more widely used. So you write a manifest file where you put your expected configurations that will be compared across actual configurations, right? Expected is, let's say you need to run 3 containers. Actual is, okay, let's say you have configured 3. Actually on the cluster there were only 2. See, this controller manager is the one which keep on watching this. It runs some non-terminated watch loops which will keep watching the cluster, which will keep on watching this cluster and identify this. As soon as it identifies this, it will again interact with the scheduler and scheduler will schedule it on the worker node. Right? That's how it will always keep watching for the expected across the actual state. Right? That's how these 3 components interact with one another before they schedule some containers on the cluster. From now on, I would say scheduling pods on the cluster because that makes more sense. We don't schedule containers, we schedule the pods. Right? That's how these 3 components interact with one another. Then comes the 4th component, the very important component, etcd. What is this etcd and why do we need it? Etcd is like a store of the cluster. Means if you consider API server as the brain of the cluster, this is called memory of the cluster. All the cluster configurations are stored in etcd in the form of key valued pairs. It's a NoSQL database, not a structured query language. It's a data is stored in the form of key valued pairs. Which data? Cluster details, cluster configurations, not the application details. Right? It's like a memory, it's like a storage where all the cluster details are stored, cluster configurations. Right? Because till now, have you wondered how does controller manager know the actual state? How does controller manager know the expected state? And also how scheduler is deciding on which node it should start a container, isn't it? It should calculate the available resources and it should start a pod on that worker node. How does scheduler know this? Isn't it? So all this information they'll get from etcd. etcd is like a storage, the memory, the very most important component where all cluster details are stored. They grab the information from this etcd and start the pods or schedule it accordingly. Got it, everyone? Is this much clear? Any questions?
So Preethi, here API server is the component which always talk to the worker node.
Sorry? Come
So
again.
here in the control plane,
Mm.
only the API server interact with the worker nodes.
API server will send instructions to the kubelet. Correct.
Okay, so
Scheduler,
no,
controller, manager will interact and send the instructions to API server back. It will be sending the instructions to the kubelet.
so scheduler is to just to schedule it, right? For example, after 3 hours, just like the cron job we schedule, it's like same like that.
It's not same like that. It may have some other process, but it is the one which decides which node to schedule, when to schedule, what to schedule. It will take all these decisions and send the instructions to the API server. API server will send the instructions to kubelet.
Okay, and the controller manager, this is also know about okay which node to select. I mean,
Control manager will not schedule it, right? Controller manager will identify if something is different deviation from the expected result. It will identify that difference and then send the instructions to scheduler. Scheduler will schedule it. API server will again send the instructions to the kubelet running on the worker node.
okay, so based on the difference only, scheduler will decide okay which worker node to create a container.
Based on the difference in the expected and actual state, controller manager will identify, interact with scheduler. Scheduler will then decide to schedule it by calculating the available resources on every node, which node is available and all, then it will schedule on it.
Okay,
And all this information they will get from HCL.
okay.
Ma'am, suppose if I want to, bring up any applications from, in worker one or worker two. So I want to interact with the API server, right? In API server itself, we can able to
You don't
install the.
have to interact, okay? You will write the manifest file. You will write a YAML file, run the YAML file. Those instructions will be fed to the API server. That is what, this is all what is happening at the back end in the cluster architecture. You just write the manifest file, run the manifest file.
From where, ma'am? Master.
Not on a master. You can write outside the master also. You connect to the cluster and run the manifest file.
Okay.
You need not write these manifest files on master. From outside the cluster also you can do that. Only thing is you have to connect to the cluster and do those, run those commands.
Remember these four things we have keep in master, right? API, server, scheduler, controller.
Correct. Those components resides on master. So if the architecture is clear, we can go and set up the cluster. And then we can start deploying the components, I mean the pods and the cluster. Let us talk about the setup now. Kubernetes cluster setup is a bit complex and varies from environment to environment. You can do the setup on-prem, on-premise. On AWS, you can do the setup. On Google, on Azure, on any cloud. Okay, on-prem kind of setup is very important. It's very complex out of any other kind of setup. If you know this setup, then you can leverage that to any cloud. On-premise kind of setup is having great demands. Many companies does this to um, save the cost on cloud. Okay, here you set up the cluster from scratch. Like you will be installing the API server components, etcd, everything from scratch, and you do that. You can also use a utility called kubeadm. Kubeadm is utility with which you can bring up this setup on-prem. This is a bit kind of alternative option rather than installing those components from scratch. We will be doing our cluster setup with this kubeadm on on-premise kind of setup. So we don't have on-prem servers. How do we do that? We will use again EC2 instances only, but assuming them are on-prem, we don't use any managed service and install the cluster. So this is the type of a cluster setup we do. Okay, with the kind of setup we do, there are certain limitations. Okay, but yeah, this is the kind of setup we do, and only setup differs. The concepts, the commands, everything remains same, whether it is on-prem or AWS or whatever. Okay, so first we'll deal with it. And coming to AWS, there are different ways you can set up. The most widely used one, EKS, Elastic Kubernetes Service, managed and paid service. Okay, this is a paid service of it, but 50% of the clusters in the market are EKS clusters. So you can imagine how widely it is used, how much demand it has got. And Google Cloud also provides a service called GKE, Google Kubernetes Engine, which is absolutely free. Prod grade cluster can be created absolutely free because Kubernetes is initially a product of Google. So it offers a service called GKE, a prepaid service. With a single click you can create a cluster. Very easy to set up. Free prod grade cluster can be used. So if you are interested, you can also go for it. Similarly, Azure offers a service called AKS, Azure Kubernetes Service. Right? This also provides a kind of service with which you can create a cluster. So every cloud offers it. So in our course, we'll be covering on-premise kind of setup. And actually, in reality, you can do everything here, like including auto scaling, everything you can do. But our lab setup has got certain limitations. So whatever we can't do on on-prem, those things we'll do on EKS, right? So that you will also get exposure to EKS. Remember, this is a paid service. Whether you do hands-on on it or you will just listen, it's up to you. But I'll be covering these two things. This is the agenda. First, we'll go ahead and start an on-prem kind of setup using EC2 instances and get started with hands-on. Later on, we'll shift to EKS cluster, where we have limitations. Is this much clear, everyone? Any questions? Right. So let's move ahead and let's go and create an on-prem kind of cluster setup. Of course, we'll be using kubeadm, not exactly from scratch, but we'll use this utility to create a cluster. All right, then let's get started.
Ma'am, on-premise is local server, right?
On-prem means like companies will have their own data centers, their own physical servers. On those physical servers, they may be having some virtual machines created. They'll use that. Means basically their own data center, let's say.
So before cloud, they are using on-premise, right?
Now also they are using on-prem will be there. It's not just before cloud, but cloud is an alternative option. But because of the huge cost, companies huge cost and also security realms, they were using their own cloud as well. Companies are using, I mean, their own data centers to create these Kubernetes clusters.
Okay.
Also, hybrid cloud is used, means some of the clusters on-prem, some of them on AWS, GCP, and so on. Okay. So now let's go to our AWS. I don't have my own data center or things like that, right? So I would be using some EC2 instances, but the difference is I wouldn't use any managed service like EKS and all, right? That is the difference. I'm creating cluster with the two nodes, right? One will be acting as a master, the one will be worker. If you want, you can create multiple worker nodes also. So these are, and one more thing, the basic prerequisite to create a cluster is it should have two vCPU and 2 gigs of memory. But here, if you know, we are using T2 micro, which will have this one, T2 micro, which will have one CPU, 1 gigs of memory. So we will bypass this exception and will create for our lab setup. That should be fine. But when we go for bigger instances, you should go for T2 medium instances. Means like if you just go here, um, mm, sorry. Yeah, here you have to choose T2 medium, a bigger instances, right? Which will have two vCPU, 4 gigs, but it would be a costly one. Then is there any other option? I will tell you. First, let me create a cluster here. I'm naming this as a master. We'll bypass this exception now, but for you to deploy, you definitely need that, right? Bigger instances. So how do you handle it? I mean, any other alternatives I'll show you other than using T2 medium. First, let me connect to both of these instances. Okay, connected and switch to root. Let me connect to this worker node as well. Okay, the pink one, let this be worker, okay? So Kubernetes cluster setup is a bit different and you should be doing it very carefully. Okay, initially I would suggest you to do this carefully by following the exact steps from the lab notes or the assignments. Don't use your own steps and don't try to mess up with the setup. Don't try to mess up because if you do something wrong, it will take some time to troubleshoot. You may lose some time doing the hands-on. So first focus on doing the hands-on, okay, by following the exact steps. Later on, you may try out whatever you want. So do it carefully. Open this, keep these steps with you, keep the steps and execute it. I'm not sure it will work or not because these are not Linux 2 instances. I have steps for Linux 2. Let's see. Let's try that out. Okay, coming to the master node. First thing is, let us set the host name. It's not mandatory, but a good practice. I would like to change the host name as master node. Run the same command on worker also. We are doing the things on parallel. But here it should be worker node 1. Let me change their host names. Set the host names. Okay. Come here and go to etc host file. Here leave those entries. They should resolve each other, right? Means each one should identify them with the host name. So put them in the etc host file. Put their IP address. First, let's go to the master node's IP, private IP, because it's a communication between the instances across the AWS account. Host name is master node. Then IP of the worker node, private IP of the worker. Host is worker node 1. Right, so these are the entries we need to do. right? So that should be done even here as well on the worker node also.
Ma'am,
If-
here we are using one master, one worker node.
Yes, white
Okay.
one is the master and this pink one is the worker node.
Okay.
So I have changed the host names and all, and also actually I'm not sure whether this is needed on this machine. There is a, if it is a like a Amazon Linux too, which is Red Hat CentOS based, there is something called security in Linux which we need to disable. But I'm not sure if this is needed here. Set N40. Maybe let me run that. Security in Linux. This is OS specific, not mandatory for every OS. That's OS specific. For all the changes to get into effect, reboot the system. Like the IP address should be resolved, the host name should be updated, security in Linux should be disabled. So I'm just rebooting those instances. And we'll connect back to install the components. Next, we'll be installing components like Cube. Now we'll install component like kubeadm, kubelet. Kubelet should be running on every worker node. kubeadm is a utility to create to manage the clusters. Kubelet is a Kubernetes agent that should be running on every node, right? And also we'll install Docker, of course, container runtime. And then kubectl. This is another very important component. Kubernetes command line utility. Command line utility to run any commands to connect to the cluster. This is the command line utility that is needed. Whether you create a cluster on on-prem or on cloud or on GCP or whatever cloud or wherever, kubectl is mandatory to connect with the cluster. See here I am installing everything on the master node, right? Actually, these components, kubelet, Docker, should be there on the nodes. Whereas kubeadm, kubectl should be there on a machine from wherever you will connect to cluster. Here I'm going to connect to the cluster from the same manager itself because I logged into master and I'm connecting from here. So we are going to install here. See, host name got updated if you see. Here also let me reconnect. Perfect. Now let us install those components. Some of the components are needed for the cluster, some of them actually from wherever you are connecting to the cluster. But in this case, I'm connecting to them from the same machine, so I'm installing them. And these are available in a different repository, so I'm creating repository file for Kubernetes. If you see, I'm creating this file, repos.kubernetes. I'm doing that on both the nodes. Now let us install those components. I'm installing a particular version of those components. If you see Docker, kubelet, kubeadm, kubectl, right? I'm installing 4 components, particular version I'm installing which is tested. Let them install, and once your kubelet and Docker are running, we can start our cluster. I think those commands are working, whichever are for Amazon Linux too. Hopefully they should work.
Preethi, what is the significance over here for the repository, Kubernetes repository?
M cannot install them because they are not available on the default M repository. So we'll be creating our own repository file telling from where it should download. We are giving this URL from where it should download. Kubernetes packages.
Okay.
That's a repository file. Even for Jenkins also we did that. If they are not available in default repositories, we'll create this in yum.repos.d folder on the system. And later on you would be able to install it via yum so that it will use these packages.
So,
So
ma'am,
one question here.
yeah, you can continue.
Okay, thank you. So here, instead of creating a repository, if we simply use a URL directly with the curl, so will that be effective? Or not.
You have to use download that binary and then installing the binary steps may differ. Using yum will be quite effective and efficient so that you don't have to struggle with the installation steps from the scratch.
Okay.
And
And one more question, like
Mm. Go on,
this
please.
kubeadm and this kubectl, I mean, functionally wise, they are same or they are doing different tasks? kubectl
kubeadm
and
is for
kubeadm.
creating, managing, destroying the clusters. kubectl is to interact with the clusters.
Okay.
See, I have installed 4 components: kubeadm, kubectl, kubelet, Docker. Okay, kubelet Docker should be there on every node in the cluster. kubeadm kubectl should be there outside the cluster from where you will connect to this cluster. Let's say I want to connect to this cluster from my laptop. kubeadm kubectl should be there. But anyhow, because I'm connecting from here itself, I'm installing them here. Okay. Now that all components are installed, I have enabled install Docker, kubelet, everything on every node. Now I'll use kubeadm to create the cluster. Command is like we did swarm init, kubeadm init, API server, advertise, IP address of Kubernetes manager, whichever node you want to act as a manager. Get those managers private IP. Also, like if you remember in Swarm, we opened certain ports for them to communicate, right? Here also same. Certain ports should be opened. So I will edit the inbound rules, add all traffic so that ports will be available for them to communicate. Okay. Uh, Now coming back, let us run this command with IP address. And one more thing, it will be giving error regarding CPU and memory, right? Because it's a 1 vCPU, 1 gibbs, that doesn't satisfy the prerequisites. So these flags ignore pre-flight errors with memory, ignore pre-flight errors with CPU. It should start a cluster. kubeadm is the one which will help us create cluster, manage clusters, delete clusters, destroy clusters, and so on. So that's what is kubeadm. Let the
Master
cluster.
node itself only we need to run this command, right? For
For now we are running.
master node itself, master node only.
For
Okay.
now we are running from master, but it could be from outside cluster. We definitely don't log into master or worker nodes. We run them by connecting from outside the cluster.
Ma'am, you have installed this kubeadm CTL, right?
Hmm.
Where did we get this, ma'am? From Docker, right?
We get which one you will
We,
get?
we have we have installed the component, right? Initially, CTL. From where did we get this?
Yum using yum command.
What's up? Like from where we get like
From
from?
the Kubernetes repositories. There are
Q-
some repositories for those packages. From those it will download.
And
And
you have,
mm,
you have mentioned Docker, right? And while installing.
mm, yes, Docker is also installed. We install Docker, kubelet, kubeadm, kubectl. And it says the control plane is successfully initialized and we are running it as a root user because always root user access may not be available. So it's asking us to run as a regular user. And also it has given us the token to run on the worker node. Do you remember in Swarm also we have this token? First, let me run this token on the worker node. This is the worker. Let us run the token on the worker node. See, it says this node has joined the cluster. Do you see that? Perfect. Now it is asking us to run as a regular user. Let me tell you one thing. Whenever you create a cluster, there'll be a folder created under etcd kubernetes. Sorry. Etc Kubernetes. HC Kubernetes. Do you see there is a file called admin.conf, right? So this is the one which is responsible for authentication and authorization. Means if you want to connect from your local, this is the one you should create. So I want to connect as a root user. So what I mean, regular user, let's say EC2 user. So what it is, it's giving me these instructions. Create a folder called .cube in the home directory. Copy that admin.conf as kubeconfig. That file is called as kubeconfig. Then only EC2 user can connect to that cluster. With whatever user you created a cluster, admin.conf file is created. If anyone else, any other user or different locations, different servers you want to connect, you need to have that kubeconfig file created, which is a copy of admin.conf. Now, because EC2 user has got that kubeconfig file, it will be in .cube. See, I just created which is a copy of admin.conf from root. So EC2 user also can connect to the cluster. How do you know? Simply kubectl get nodes. This is where kubectl is used. Do you see the difference between kubeadm and kubectl now, everyone? So this will list the nodes in the cluster. See, means it's able to connect. Got it, everyone? Two nodes it was showing. One is a master node, the other one is worker node, right? And cluster is ready with the two nodes. And why they are not in ready status? Status is not ready. And where is this API server, scheduler, etcd? Everything in a cluster will be running as a pod. You can see those pods with the command give ctl get pods minus a means all pods. See, they are all deployed as pods. Do you see? HCD, Cube API server, controller, Cube proxy, scheduler, some of them are still pending state. That's why nodes are also pending. And also for them to communicate, we have to install some network plugins. And I'm going to install Calico network plugin. What is this? This is what is a manifest file. I'm talking about, right? We deploy anything as a manifest. So there are standard manifest files to run the Calico plugins. So install that as well so that your code nodes can be communicating and be ready. We'll see manifest files later, okay? But just understand deployed some standard ones and kubectl get nodes. They should be ready once all the pods are in ready state. Do you see pods are still coming up? Calico pods came up. Once these pods are ready, your nodes will be up and ready status to take the load. Is this much clear, everyone? Understood? Any questions? Anything you want to install in a cluster, they would be installed in the form of pod.
This Calico interface is our network, network
Network plugin.
plugins, right?
Network plugin so that it
So
takes
this,
care of it takes care of
so,
communication between the components.
use this network plugins, we can able to communicate each nodes, right? Master to worker,
Yeah.
worker to.
Yeah. See, now they are in ready status, right?
Before you run on tokens, what is the purpose of the tokens now? That is also communicate to each other, right?
Token is to add a worker nodes to the cluster. Like we did a token in the swarm also. If you want to add a worker nodes, you will run the token on those worker nodes. Right? That's the same thing we did here also.
So without this network, plugins, we can't able to communicate each other.
Right.
Okay.
So, okay, fine. Let's suppose you want to deploy some pod, right? Let's say I want to deploy my Nginx image, correct? Shall I go ahead? Good to go. Kubernetes always prefers declarative approach, means write a manifest file. But we also have imperative commands. Docker run nginx is the pod name, or else I would give the name as sample is my pod name, image is nginx, and it runs on the port 80. So that's an imperative command that will create a pod. See, it is taking some time, right? Because like I told you, these are T2 micro with one CPU, which doesn't suffice the prerequisite to be a part of the cluster. It would take some time. As you go on, it may take more time and hung up. So see, one pod is created. It is still in pending state. Get PO is the short form for pod. If you want to know where it is running, describe pod. See, it will show you the labels, everything. Actually, get pod with output wide will show you here itself with inputs as where it is deployed, where it is running. See, it is taking quite longer. If you have enough resources like a T2 medium instances for cluster, this wouldn't be the case. Okay, so this is where you create a pod, right? Just a sample for the pod. We'll deep dive into this, but okay, this is how you create a cluster. I would like to show you another option how you can create a cluster. For your learning particularly, you can create a cluster which is a single node cluster called Minikube cluster. There is something called Minikube single node cluster for lab and for learning you can use it. This can be installed on your laptop, or if it is Windows, Mac or Linux. You can also take some EC2 instance and install this Minikube cluster. It's a single node cluster. Again, the setup is different, means you only laptop, but still you can run your cluster, right? So it's just for learning. So you can go, if it is Linux, go with these steps. If it is Windows machine, go with these steps and install. If it's a Mac, this is how. I have installed it, and I can go to my Mac, my laptop. I can show you this because see, now it came up, but still it's taking time to get started. Do you see here? Nominated node means on which node it will run. It should give here the worker node, but it's just hung up. Let me show you starting a Minikube cluster. But before starting Minikube cluster, you should start Docker, because Minikube will be running as a Docker container. Let me start Docker. Docker desktop started. Now go to the terminal. Let me create a new tab. Okay, as Docker is started on, this is on my Mac, Minikube start. That will start the cluster. Cluster will be started. See, it's pulling an image. It will be started as a Docker container. Whatever it is, don't worry about at the back end. Just try to understand. You can create a cluster and learn Kubernetes. This is very much handy, helpful for you to do the hands-on without being extra charged. Okay, it says cluster started. Let's see. See again, kubectl. Like I told you, right? Kubectl is a command line utility. Whether you connect with a cluster on on-prem or AWS or GKP, this is the command line utility. Of course, you have it to install this on your laptop also. Now get nodes. Single node cluster. It will show only one control plane, but that's okay. You can run the pods, deploy them here. It's a new cluster, but okay, already some of them were there. Just ignore it. Okay, I'll run a run sample from image equal to nginx with a port 80. Okay, pod, see how quick it is, whereas it was taking time over there, right? See, pods, if you want to see where the pod is running, it should show worker node, but because it's a mini cube single node cluster, it will show this node mini cube. Otherwise, it will show worker node name here, worker node source name. Am I making sense? Default pods you can see with the minus A. See, default pods are core DNS, Q proxy, everything. Ignore all of those in different namespace. Okay. Is this much clear, everyone? Kubectl get pod. Our pod name is sample, right? This is the one we just created. It's a running state. If you want to see more details, describe type of the object is a pod, name of the object is sample. So here you can see where it is running, minikube node it is running, and this is the IP address of the pod, container IP, image that is running, nginx image, started time, all the details. And if you remember the architecture I told you, right? The architecture of Kubernetes. So you can see those events. First, we discussed like it will successfully assigned this to minikube, means it has successfully assigned to some worker node. Pulling this image nginx successfully started the container. Container created, container started. These are the steps that happen. Scheduler is the one which scheduled it. Kubelet is the one which started it. Do you see that? Everyone? So whatever we learned in architecture, you can see. Scheduler scheduled it to minikube node or worker node. Kubelet then started pulling the image, started a container from that image and started the pod. Are we good? So I have used the imperative approach. This is the imperative approach, right? By running the command this way. How do you deploy it in a, like this is the imperative command. Imperative commands are useful to quickly do something, or in the certifications this might be helpful. But in reality, we use declarative approach through manifest files. So we'll do that. And there are something called namespace. Namespace means it's to segregate your different applications. These are all the default namespaces, but one is there which I created. Let me delete. kubectl delete namespace Prometheus. We'll learn that, okay? We'll create it again and we'll learn the use of it. I'm just cleaning up the cluster. These are from the previous ones, might be. We will learn Helm as well. I'm just cleaning up. Perfect. So this is the pod we created, and these are the different default pods created during the cluster setup. Okay, coming back, yes, this is our cluster pod running on the worker node. Of course, because it's a mini cube, it's running on mini cube node. Now I want to deploy it as a default. I can clean it up by and create it in the declarative approach. How do you delete it? You can delete the pod. Delete pod. Pod name is sample. It's pretty quick and faster here, right? So pod is gone. Now we'll create in the declarative approach using a manifest file. So how do you write a pod manifest file? I think we shall get started with this from the next class. Before that, get your cluster setup ready, whether it is on like EC2 cluster setup or else on your laptop using Minikube, anything is fine. Only setup differs, the commands concepts remain same. So it's up to you. It is taking some time, I believe. It's just getting hung. So better we can go with the Minikube cluster. You may create Minikube cluster on EC2 instance also. Take one EC2 instance and create it. That is also fine. Any questions from anyone in this part? Cluster is ready. Now we would do scaling the pods, deploying the
Ma'am,
pods. Hmm.
ma'am, you are increased I mean that memory level. I mean the CPU memory is 1 to 2. So how to check
I did not increase it. I'm using my own laptop. I started Minikube cluster on laptop. I did not increase the resources. Oh, you are saying how to increase those? Are you asking that?
yes, ma'am.
You have to choose here. We are using T2 micro, right? T2 micro, 1 CPU, 1 gips. So
Yeah,
this,
that is free only, ma'am. But the 2 GB memory means it is I mean paid service, right?
so T2 micro is 1 vCPU, 1 gips, which is not satisfying parameters to create a cluster. So you should create here, choose a bigger one, T2 medium, which offers 2 vCPU, 4 gips. This is a paid one, not free. You should use cluster by creating this. That's why create it from Minikube on your laptop. Any
So we can use the mini cube. We can, I mean, don't use this. I mean, paid account, right, ma'am?
right, right.
And one more question, ma'am.
Mhm.
I mean, we earlier we are created the I mean network plugins for master node. So
Mm,
that is the purpose of I mean to interact with the master to working node. So
mm,
suppose I am going to I mean create another one working node.
mm.
So how to communicate? I mean in
Just run the same token. You have got the token, right? You need to run the token on the new worker node. That's all. We have installed network plugin on the cluster, not on any particular node.
okay, okay, ma'am.
Those are cluster-wide components.
So in master node itself also that we need to create that file. I mean the private IP also. I mean open node private IP also we need to
Yes.
mention, right? That
Huh.
etcd.
Mm,
Okay, okay,
we have.
okay, okay.
I'm destroying the cluster from here. I'll be doing the hands-on with my mini cube. So I'm destroying this cluster. You can go with any type of cluster setup. Any more questions? And if you want to stop your mini cube, you can do mini cube stop to stop. Mini cube stop. That's all. That will stop the cluster. Later on, you can start again and keep going. Right? Now you wouldn't be able to run those commands. It's giving error. So that is all for today. Keep going with the hands-on. Let's continue from here in the next class. Thank you all. Good day. Bye, everyone.
Thank you.